Wait, so we're not supposed to do that?
So don't do that yet. You might be able to, but we're going to work through this together. The bottom of the Things I Know worksheet here. This is f prime. That didn't show up real well. That is the graph of f prime. Almost always, I and AP will say something like, this is the graph of f prime, not the graph of f. We're not trying to trick you, but we need you to know that this is not the graph of f. This is the graph of the derivative. This tells me the slope of f. So we have to be real careful looking at this graph because it's not the graph of f. The figure above shows the graph of f prime, the derivative of a function of f. We're trying to make sure you get the idea that ain't f. The domain of f is a set of all real numbers between -3 and 5. Okay. For what values of x does f have a relative maximum? Okay, well, don't look at the picture. First answer the question why, and then we'll look at the picture.
F prime changes positive to negative.
There's a relative max when f prime changes positive to negative. That's what a relative max is. When f prime changes from positive to negative. Well, I have a picture of f prime. This is the graph of f prime. So I would like to know when that graph changes from positive to negative. So at what x value does this graph, does this graph of y, does this graph of f prime change from being positive to being negative? So it's positive here. The graph is positive, positive, then it's negative, 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 negative. Right here the graph goes positive. So where does the graph change? Not the slope of the graph. Where does the actual graph change from being positive to negative? At -2. The graph changes from being positive to negative at x equals -2. Part B. For what values of x does f have a relative minimum and why? Well, again, don't look at the picture first because the picture is confusing. Because here's what your brain does. Your brain reads relative minimum. You look at the picture and you're like, oh, look, I know what a relative minimum looks like. It's those 2 points. But this is where does f have a relative minimum, and this is the graph of f prime. So cover up the graph, answer the question why first, and then use the graph. F has a relative minimum when f prime changes negative to positive. So now look at my graph, and you're looking for where does f prime, that's the graph, where do the values of this graph go from being negative to being positive? X equals 4. Okay, so you really have to be careful because your brain is really good, right? When your brain sees relative maximum, you know what a maximum looks like, so you immediately start looking for the top of a mountain. But this is not f, this is f prime. Part C. On what intervals is the graph of f concave upward? Use f prime to justify your answer. So we're concave up when f prime, we said this on the Things I Know worksheet, when f prime is increasing. When f prime is increasing, f is concave up. So look at our picture. We want to know where f prime, but this is f prime. So I want to know where this graph is increasing. So from where to where is this graph going up? -1 to 1 and 3 to 5. Again, I don't want to know where the graph is concave up. I want to know where the graph, where f prime is increasing. Suppose that f of 1 equals 0. Draw a sketch of the general shape of the graph of the function between 0 and 2. So f of 1 is 0. So I can put a point there. Put it where you can see it. So between 0 and 1, I want to make kind of a table here. And I want to know stuff about f prime and f double prime. So between 0 and 1, what's f prime? Based on my graph that's up there. Positive or negative, that's all I care about right now. What's f prime between 0 and 1? Well, f prime is increasing, that's true, but right now I only want to know positive or negative. It's negative. Now, because it's increasing, you're right, because don't say if, note to self. Because f prime is increasing, what does that mean about f double prime? Yeah, well, it means f double prime is positive, which means concave up. So I need to be decreasing, but concave up. So I need to be decreasing, because f prime is negative, but concave up. So I need to stay decreasing, but you're right, it needs to be kind of bold up. So decreasing, but concave up. I guess I could add a row there about f. F is decreasing, but concave up. All right, between 1 and 2, what's f prime? Positive or negative? Between 1 and 2. Negative. What does that mean about f? Decreasing, so I need to stay decreasing. What about f double prime from 1 to 2? See, f prime is decreasing, so f double prime is negative. So concave down. So I need to be decreasing still, because f prime is negative. So I still need to be going down. But now, instead of being concave up, I need to be concave down. So decreasing, concave down. Yeah, Connor just drew it, and there it is. Some of you are drawing it in the air. Decreasing, but concave down. So something along those lines. Let's see if we can draw a picture for number 1. I'd hope to get through 1 and 2, but may only get through 1. So, sketch a graph of a continuous function, so nothing crazy, which satisfies all the following conditions. F prime is less than 0 for all real numbers except 4. F prime is less than 0. What's that mean about f? F is decreasing. So I'm going to be going down the whole way, although something weird is going on at 4. We'll worry about that in a minute. Oh, f prime of 4 does not exist. Okay, if f prime doesn't exist, what are some cases that make a derivative not exist? Okay, asymptote, that's one possibility. What else? Cusp. What else? A jump.
But it's continuous.
Yep, it's continuous.
No jump.
So no jump. I would say one more thing, and that's a vertical tangent line. It's also continuous, so we can throw out asymptote. So we either have a cusp or a vertical tangent line at 4. So I'm going to put 4 on there because something weird is going on at 4. F double prime is less than 0 for x less than 4. So what does that mean if f double prime is less than 0? Concave down. So I like to label it on my graph. So when we're less than 4, we're concave down. When we're greater than 4, what's that mean? Concave up. So I need to be decreasing the whole way, but I need to be concave down. So decreasing concave down until I get to 4. And then 4 is either a vertical tangent line or a cusp, either way. And then I need to be decreasing concave up. So I need to sort of make this a sharp turn. Decreasing but concave up. All right, try the rest of that worksheet. But you can throw out number 4. Throw out number 4 on the back. So try 2, 3, and 5. We'll check them out on Monday and see how we stand.